Predicting the relative acidity of binary acids. So a binary acid just means that you have hydrogen bonded to one other element. So the generic formula of a binary acid will be HXH. Being hydrogen, that's the proton that's going to, be ionized when that acid dissociates, and X is going to be some monoatomic anion. Okay, so for instance, HCl, hydrochloric acid, would be a binary acid. So we're asked to predict relative strength of binary acids. So two factors affect how strong this HX bond is. The stronger the bond, the less strong the acid, because it's going to make it harder for it to give up its H plus. The weaker the bond, the stronger the acid, because acid strength is measured by how much H plus it can give up, how easily it loses a proton. Okay, so we are asked to look at binary molecular compounds of hydrogen in a group 6A, which is what we would call group 16, depending on if you're calculating using the old or new numbering system. Okay, so nowadays they're mostly just numbered 1 through 18. Some older numbering systems uh, miss out the transition elements in the middle, or just go 1, 2, and then skip to group 13 and call that 3A, etc. But we can speak both languages, right? Anyway, I digress. So we're asked about hydrogen selenide, and we're asked for something that is less acidic than hydrogen selenide. So let's go find hydrogen selenide. Where's selenium on the periodic table? It is here. Okay. So maybe I should pick a different color. That's a bit easier to spot here. Let's pick this obnoxious pink. Here is selenium. Okay. So if we're thinking about the strength of that hydrogen selenium bond, and we want something in the same group that is going to be a weaker acid, what we're looking for is something with a shorter bond. Okay, so anything above selenium in the periodic table is going to be smaller, right, because it has less shells of electrons around it. So oxygen and sulfur will have a smaller atomic radius than selenium. Okay, and tellurium will have a bigger atomic radius. So if we're talking about a weaker acid, that's going to be having a shorter bond. So that would be oxygen and sulfur. So shorter, I can't spell, shorter bond to H, which means it's going to be a weaker acid because it's harder to give up the proton, which is going to respond with a lower Ka value. Okay, so possible formulas then would be H2O or H2S. Those are our two options that would be weaker acids. So just as an FYI, tellurium, the HTE bond would be longer. Longer bonds are weaker. So it's going to be a better proton donor. So that would be a stronger acid, but that is not what being asked in this question. But, I thought I'd cover it anyway, just so you can see how that works in terms of the periodic trend.